TCP/IP stands for Transmission Control Protocol Internet Protocol, and it's not actually a protocol on its own, but it's actually a suite of protocols, and we need it to make sure that all sorts of different devices can communicate with each other over the internet. So the TCP/IP network, it provides a framework for transmitting this data, and it, along with it, needs some basic information from us or from your computer in order to communicate that data. So we need to specify if we want the most reliable or the fastest transmission, and we also need to specify where we want the data delivered. Sometimes it's routed based on an IP address. So an IP address is used to uniquely identify each host. They are virtual addresses assigned by routers, and each of the four 8-bit fields is represented by a decimal number ranging from 0 to 255. So an example could be 192.168.0.1. It might also be routed on its MAC address. Now a MAC address, unlike IP addresses, which are virtual, the MAC addresses are fixed on the hardware, so they're programmed on your device. So when you have your new phone delivered, it has a MAC address already programmed on it. It contains 6 8-bit fields expressed as hexadecimal numbers. So all this information that we've just talked about needs to be sent along with the data that you obviously want to transmit. And you also need to physically transmit the data from one location to another, be that via wireless such as Bluetooth or Wi-Fi, or along a network cable. So this basic information needed by the TCP/IP needs to be in a format that the network can understand, and the method that you need to be aware of is the 5-layer model. If you're researching on the internet, you'll also see a 7-layer model, but as I said, for your exam you need to understand the 5-layer model. And each layer only communicates with its adjacent layer, so the one above or the one below it. So the first layer we're going to look at is layer number 5, which is the application layer, and it's where all the applications requiring the network communications live. So that could be an email client or a web browser, and these applications use the transport layer, which is the one below it, to send requests to connect to remote hosts. So it could be a web server that you're trying to download a web page from. Okay, so layer 4 is the transport layer, and this establishes connections between the applications running on the different hosts. So for a reliable connection it uses TCP, and it uses UDP for a fast connection. And what it does is it keeps track of the processes running in the applications above it, and it assigns port numbers to them, and uses the layer below it, the network layer, to access the TCP/IP network. Layer 3 is the network layer. This is responsible for creating the packets that are going to move across the network, and it uses the IP addresses to identify the packet source and its destination. Layer 2 is the data link layer. This is responsible for creating the frames that move across the network. So these frames encapsulate all the packets, and they use the MAC address of the devices to identify the source and the destination. And finally, layer 1 is the physical layer. So this encodes and decodes the bits found in a frame. It also includes the transceiver that drives and receives the signals on the network. So it's the actual physical connection. Okay, so without seeing an example, that sounds quite confusing. So you know the primary job of each layer now, but like I say, you need to see how they all work together in order to understand it. So we're going to have a look at a simplified view of how they all work together. So the higher layers are going to pass information to the lower layers, and then at each layer a header is added to the data, and it contains information that it needs to perform its job. So we'll start at the top with the application layer. So if we say that a web browser is trying to download a web page, at the application layer it generates a message. It's then sent to the transport layer to say I want to download a web page from the address 192.168.1.102. Then the transport layer adds a TCP, or if it needs a fast connection, a UDP header, which has the source and the destination port addresses. It might also include information such as the packet sequence that's going to be used, and then it's all passed down to the network. So then the network layer adds its header in, which has the source and destination IP addresses in order to generate the packet, and then the packet is then sent to the data link layer. So then the data link layer adds a header which contains the MAC address in order to create a frame, and then that frame is then sent to the physical layer in order to transmit the bits of data. This table here summarises some of the terminology. So you've obviously got the layer number and name there, and the protocol that's being used, then also the data units that are being sent, and the addressing that's being added to the header. If you want to pause the video now and just have a look at that, feel free, because the video is about to end.